Hello everyone, welcome to my video. So today I'm going to discuss trees data structures. So let's get into it. So what is a tree? So this is a tree, but this is not the tree that we are going to discuss today. So basically, tree is a data structure that is non-linear. Non-linear. So it's a non-linear data structure. So unlike stacks and your queues, I think you know that already. So in our stacks and queues, the nodes are connected linearly, linearly in a linear pattern. So in trees, the nodes are connected. So one node is connected to multiple nodes. No? Allow me to show you a visual representation of what a tree is, so it's more understandable. So let's go. So what is a tree? So basically, a tree is a non-linear data structure. To compare it with our previous data structures like the stacks, the queues, the arrays, and the linked lists, these types of data structures are what you call a linear data structure. It is called a linear data structure because the nodes or the data of this type of data structures are connected in a linear manner or a linear pattern or in a linear progressive pattern. So unlike the linear data structures in trees, uh, its nodes are connected to multiple other nodes, or it is connected to only one node, or it is not connected to any nodes at all. It is not connected to any node. So what are the parts of the tree? So first, most of the trees follows a top-down manner. So which means it's always most of the time it starts from the top. So it resembles more like a tree or its branches. And so in our trees, uh, like the A here, this is what you call a node, while the line that connects them is what you call an edge. Alright, so as you can see in a tree, there are lots of nodes connected by lots of edges. Alright, so the first node in the tree is what you call the root node. Alright, then the other nodes that are connected to the root node are what you call children. Sorry, children node. Right. So of course, if there's a children, then of course there's a parent. So you can say that the parent node of nodes B and C is the node A. Right, so it's just like that. So, and uh, some nodes like our node D here, nodes that do not have children or does not connect to any other node, is what you call a leaf node. Yes, leaf, just like in a branch. But the leaf is the last part of the branch, right? So that's what we call it, a leaf node. Alright, so we already know that node A right here is the root node, and if it has descendant nodes or nodes connected to it, we call it the parent node. And the nodes that are connected to the parent node are called children nodes. And if a node doesn't have any children, so you can call it a leaf node. So I made a drawing right here. It's more of the art part of the trees. So start from the root A, then travels to let's say the node or branch B connected with the edge, and it has a children node which is called the leaf node B, also have leaf node F, G, C. So right, so it resembles a branch of a tree. So to traverse the tree and its nodes, we have four. Just first is the level order, second is the pre-order, third post-order, fourth is the in-order which is in-order traversal. So in the level order, it traverses the tree by level, just like right here. So this is the first layer, which is the 0th level, because A here is the root, right? Then the second layer is the node B and C, then the third layer, and the fourth layer. And you count the nodes from left to right. Right, then next we have the pre-order. So what it does here, how to do this is you start from the root, then you go to the left node, then you go to the right node. So these are the result. This is the pre-order traversal of our tree right here. And just pause the video and try to analyze the nodes. So in post order, it starts from left node, then right node, then to the root node. This is the order. And in order progression, a traversal, you start from the left, then you go to the root, then you go to the right node. And also this is the order. Alright, so we're going to discuss tree traversals because this is one of the most important parts in the trees. So we know that in the level order traversal, you just start from the top level, top layer, then you go from left to right. You count each node from left to right. Alright, so in the pre-order traversal, so we know that when counting the nodes, you start from the root node, you go to the left node, then you go to the right node. Alright, so what happens here in our example tree here, since we start from the root node, and our root node right here is A, then this is our first. Then go to the left, right? So our left here is B. It's the second. Next we should go to the right? So but since B here is a parent node, has children node, so in this triangle, the B here is the parent node, right? So this is the top, the root node. So what happens here is you go to the left node, right? So D here is next. It doesn't go to C here because it still has children nodes. Then, alright, since following the format, you root, you go to the left and right. Now we are down the left, which is at node D here. Then we go to the right, which is E. So this will be our fourth. Now this is the top, right? E here has children node, so this becomes the top. Then, so it goes to the left, go to the left, this becomes 5, and go to the right, 6. So since this is the last, so the children nodes of B node right here is finished, it's done. Then you go to the next, right, which is the right node. So C is the 7. Right, so that's how you do it. So all in all, it's A, then B, then D, then E, F, G, then lastly C. That's how you traverse it. In the post-order traversal, which is you start from the left node, then you go to the right node, Then you go to the root node. So in the same tree, so you're gonna traverse it. So you start from the left. So what happens is you start from the left, right? Start from here, you go to here. But since B here has children nodes, so we find its left node, which is D. So we start from D. This is our first. Then left, right, root. Then you go to the right, which is E. E here, right here. But then the E node here is a parent node. It has children node. So what happens is you go to the left node again. You start again in the order. Start from the left. So our second here is F. Then you go to the right, which is G. This is our third one. Then you go to the root, which is E right here. D, F, G. Yeah. So this is our fourth. Then since the last in the order is root, so you go back to the B. Which will be our fifth. Right? Then you go to left. This is the left is complete. Then you go to the right, which is here, right? So which is C. So this is 6. Then you go to the root, which is the last. So 7. So all in all, it's D, F, G. Oh, sorry. D, F, G. Fourth E. Then B. Then C. Then A. All right. So go to the next. So here in order traversal, the order is left, root, then right. All right. So what happens here? Start from the left, just like our pre-post order traversal. You cannot go a right directly to B here because B has children nodes. So we start from the left. Just D. That's our first D. Then you go to the root. Just B. Right? This is our second. Then you go to the right, which is E. But D, B, F. Yeah. But E here has children nodes, so we start again from the left, which is F. Yeah. Then you go to the root, which is E. Yeah, 4. And you go to the right, G, which is the fifth. D, B, F, E, G. Right? Now the left node, B, is complete. Then you go to the root here, which is A. This is our 6th. Then you go to the right, which is C. Now this is our 7th. So if you put them in order, this is D, you go to B, you go to F, then you go to E, then G, then A, then C. Alright, so that's how you do it. That's the in order traversal. So since there are many types of trees, I will just show you the most important or most commonly used types of trees. So at most there are at least 5 types of trees. First is the general trees. Second is the binary tree. The third is an expression tree. Fourth is a binary search tree. And fourth is the AVL tree. So what is a general tree? So a general tree looks like this. The nodes are not limited; they are unlimited. Meaning it can, so one root can have as many children nodes as many as it can be. It can have just 1 or 2 or 3 or so on and so forth. So it's just like a normal tree, just like a normal branch outside. It's just general or generic. Second, we have the binary tree. So an example of a binary tree is right here. So a binary tree has at most 2 children nodes, just like our tree right here. So the root node has 2 children nodes, and node B right here, which is the parent node, has also 2 children nodes. So there are also many types of binary trees. We have the strict binary trees, wherein strict means it is either only 2 or none children trees. You can have only either 2 or none or 0. And we have the full binary tree. In that type, that kind of binary tree is all the parent nodes have exactly 2 children nodes. So every node has 2 children nodes, and the leaf nodes are at the same level. Alright, so next is the expression tree. So what it does in expression tree is it deals with expressions like in math. So example of our expression tree right here, we see this is the division sign, the addition sign, this is the multiplication sign, or the asterisk, or you can just say it's the x sign. Alright, so what happens here in expression tree is that you read this, you traverse this through a in order traversal. So an in order traversal follows a left root then right traversal of the nodes. So if we do an in order traversal right here, and this in our expression tree, this is what the result would be. This is what the order would be. No, so it's a plus b, a plus b times c, and it goes to the top, divided by d, which is the right node. Right. And so, in addition, in binary trees, there are also its traversal in binary trees also follows the 4 types of traversals we discussed earlier: the level order, pre-order, post-order, and the in-order traversal. So back to where we left. In AVL trees, this kind of tree is that its height on the left subtree and the right subtree is 1. It's just the distance is just one node away, something like that. Such that if just like in our second, so this is what you call an AVL tree. So in the second tree, you can see that from root B it extends to node A, which is the children, and it also extends to the node B. So the height in the left side is 1, 2, right? 1, 2. And from the right naman, you have the C node, it's only 1. So it's not the same, it should be 1 only. So it's not an AVL tree. So what it does here is just you try to rotate the nodes, or when there is insertion or deletion of the nodes, that's when you can arrange the tree again, so it would be back to an AVL standard tree. So right, so these are all the trees that you need to learn, you need to know more about. Right, so thank you for listening, and I hope you learned the basic knowledge in trees. So thank you very much. So that's it for today, guys. Thank you for watching my video, and I hope you learned everything you know, everything you need to know about trees. So until next time.